Hello class, welcome to Geometry, Lesson 4.3, which is all about proving and applying the side angle side, or SAS, and side side side, or SSS, congruence criteria. By the end of this lesson, I can use SAS and SSS to determine whether triangles are congruent. So remember, congruent means the same. So let's look first at our theorem 4.3, side angle side, or you'll always hear me say SAS, or almost always. I use it frequently. Side angle side is when you have two separate triangles, and you can see that we have two congruent sides. So in this picture, ST is congruent to YZ, and then RS is congruent to XY. That's what our diagrams show us. And then between those two sides, so the angle formed by those two sides is called an included angle. If my two included angles are congruent, then that is enough information to say that the entire triangle is congruent. So I have a side, I have an angle, and I have a side. And I still have a side, angle, side, or SAS. Using that, I can say that triangle RST is congruent to triangle XYZ. So let's say we have two congruent triangles. So you can see if I have triangle ABC is congruent to triangle XYZ, then I can say, since I started with AB, I can say AB is congruent to XY. So I say that. Those two parts, wow, my smartboard freaked out. Those two segments are corresponding. Then I have BC and YZ would be congruent to each other. BC and YZ would be congruent to each other. After BC and YZ, I could say that AC and XZ are also congruent. So AC and XZ are congruent. Then I can go into the triangle and I can say that angle A would be congruent to angle X. So if I look, angle A is formed by the green and then like the bluish green line. Angle X is formed by the green line and the bluish green line. And then I could say that angle B is congruent to angle Y. They're both formed by the purple and the bluish green line. And then angle C would be congruent to angle Z. They're both formed by the purple and green lines. So that is called corresponding parts of congruent triangles are congruent. That is a lot of words. This is probably the most challenging acronym I make you memorize, but you have to memorize corresponding parts of congruent triangles are congruent. CPCTC. The way that I remember it is C occurs every other letter, and we have PT between it. So CPCTC. Whatever you need to do to remember that and memorize that, you need to do it because you're going to be using it for the rest of geometry, okay? Then we talked about side angle side. Corresponding parts of congruent triangles are congruent. And now let's talk about side, side, side. So if I have two triangles and I see that my two triangles have three congruent sides, I can say that those two triangles have to be the exact same or they have to be congruent. So that's called side, side, side. All right, so let's do a proof. We want to prove that these two triangles are congruent. So I'm going to do a two-column proof. And with this two-column proof, I need to start with the given information. So if I look at the picture, I can see that DC is congruent to AB. So I'm going to say DC is congruent to AB, segment AB. That is given. Another bit of information that is given is I have that little arrow that means that they are parallel. So I can say DC is also parallel to AB. So So that's all given information. Then, if I'm trying to prove that these two triangles are congruent, so if I look, that's me trying to say ABC is congruent to triangle, let's see, CDA. All right, so the two ways I can prove that triangles are congruent is by side, angle, side, or side, side, side. So if I look at this, I have one congruent side. And if I also look, here's one triangle. And my other triangle, if I outline it, notice how there's one line in that picture that overlaps. It's both purple and red. That's the same exact line. So what I can say is AC is congruent to AC because it's on both of the triangles, and that's called the reflexive property. That's something we talked about way back in the beginning. That's whenever you have something is congruent to itself. So we have a second side. So we have two sides are congruent. Now we either need to be able to prove that the third side's congruent, or we have to prove that we have a congruent angle. If I want to prove that we have a congruent angle, things get just a little bit trickier. I have parallel lines. Remember back in chapter 2, we talked about angle relationships between parallel lines? So here's my two parallel lines, and I have a transversal cutting through it. So I could say that this angle is congruent to this angle. If I did that, if I redraw just to help see, if I say this angle is congruent to this angle, that would be by alternate interior angles, right? If I get rid of the sides of the shape, it might be easier to see. And if I extend, you might recognize it now, that those are alternate interior angles. So if I go back and I redraw the figure and use the letter names, I can name these angles. So this was A, D, C, and B. So angle BAC, so angle BAC is going to be congruent to angle DCA. And that's by alternate interior angles theorem. So now I have, on my original picture, I have two congruent sides and I have an angle. Now I need to make sure, is my angle included between my sides? Because my alternate interior angles, I could have also chosen these, right? Those are also alternate interior. But the bluish green ones are not the included angle. So I have side, and then there's an angle that's touching the other side. I have a side, I have the angle that's touching the other side. So I know that that's included. So now I can say triangle ABC is congruent to triangle CDA. And that's by the side angle side theorem. Okay, so that's how you would do a proof to prove that those two triangles are congruent. So if we look at example 2, we want to determine congruent triangles. So which of the following pairs are congruent by side angle side or side side side? So if I look at this first pair, I see that I have one congruent side, I have two congruent sides, I have three congruent sides. That means that this one is going to be congruent by side, side, side. If I go to the one right below, I have a side, another side, and then an angle. So since my angle isn't between or touching both of my sides that I have information about, I can't say that they are congruent. So not enough info. Now if I go to this pair and I look, I can see that I have a side, an angle, and a side. They're all in order. So let's see if that happens on the second one. Side, angle, side. So these two triangles are congruent by the side, angle, side. And our last one, if I look, I see I have a side, angle, side, side, angle, side. And if I go down and I look at these triangles, I want to figure out what additional information do I need in order to show that these two triangles are congruent by side, angle, side. So right now I have a side, angle, I have a side, angle. So I need that side, angle, side, angle, side. So the drawings that I added in, I needed, let's see, for the side, angle, side, I have to add AC, segment AC has to be congruent to segment, FD. And for side, 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 I would need that third side, right? I would need BC is congruent to FE. And in order to be side, 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 I would also need the side that we added in for side, angle, side. I'd need AC is congruent to FD. So that's all of the information I would need in order to solve that. So why don't you look at letter A and see, is triangle STU congruent to triangle XYZ? If it is, tell me, is it side, 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 or side, angle, side? If it is not congruent, say not congruent and tell me what you would need to add in to make it congruent. Good luck. Hopefully you said that these were congruent by side, angle, side. If you have any questions at all, please feel free to reach out for some help. Here's a quick concept summary, and I hope you guys have a fantastic day.